Hi, good afternoon. Welcome to the final session of the afternoon. It's been a fantastic opening day for the RIC. I'm Michelle Sampson, Director of the Division of New and Renewed Licenses in the Office of Nuclear Reactor Regulation. I'm pleased to be chairing this session, Critical Links, Strengthening the Nuclear Supply Chain for Tomorrow's Reactors. Please feel free to make your way towards the front of the session room. There are plenty of seats available. If you need to leave during the session, we would appreciate, if possible, to wait for a natural break or transition. A couple of housekeeping items: please silence your electronic devices, and a reminder that all of the sessions are being video recorded. The Q&A and a live polling question will be handled electronically. The QR code on the screen can be scanned and will take you to the site for this session, where you can access the poll question, the Q&A, and provide session feedback. For the live polling question, your answers will be combined with the other group members, and we'll have a group answer a little later in the session. You would text your answer choice to 22333. At the NRC, as you've heard several times today, we are transforming the way that we do business to ensure we are safety-focused, technologically rigorous, and enabling new nuclear power to meet the country's growing energy demands. But in the true measure of success, it's not completing a 16-month review. It is shovels in the ground and ultimately the safe and secure nuclear operations that provide electrons on the move. Supply chain is a critical link to enable new nuclear power. Today's panel brings a wealth of real-world experience with both prior and future new builds. They have all reflected on the opportunities and challenges with supply chain. Today's poll question is to gather your insights on the challenges we face with effective supply chain. Recognizing that the U.S. must modernize and expand its nuclear fleet, what are the biggest bottlenecks for today's supply chain? And if we could show the poll question on the screen. Great. The options are A, limited manufacturing capacity; B, quality assurance requirements; C, workforce expertise and qualification; or D, raw material availability. Please text your selections, A, B, C, or D, and we'll check back in shortly to see the overall results. So to support the whole of government approach, Team USA, at the NRC, we have been looking holistically at our regulatory program, from pre-application interactions through construction and, of course, future operations. We have been developing informational commission papers to lay out the staff's considerations on a number of topics. Last August, we issued SECI 250074, Expedited Construction of Certain Structures, Systems, and Components, which laid out the staff's strategy to provide more clarity on which components fall within the regulatory definition of construction and which do not. Too broad of a definition of nuclear construction may unnecessarily restrict construction of new nuclear power plants, with the potential effect of limiting the ability to apply modern construction techniques and optimize construction schedules. Some of the staff's considerations and the regulatory pathways, including exemptions that can be applied to support expedited construction, are discussed in the paper. We'll be talking about construction in more detail tomorrow in session W8, Building Smarter, Accelerating Advanced Reactor Construction. Today's topic, supply chain, is an integral step supporting construction and operation. In July 2025, the Nuclear Energy Institute submitted proposed guidance to support expedited procurement of long lead items, NEI 2505, fabrication of ASME code items prior to the identification of an owner licensee. In recognition of the need for addressing a new business paradigm that seeks to expedite construction through early procurement of long lead items. These challenges and opportunities are front and center in planning for construction of new large light water reactors. In the next few weeks, you will see another information paper from the staff that highlights our readiness to leverage the efficiencies that are available for future licensing of new large light water reactors, including pathways to reinvigorate the combined licenses that were issued in the past but never constructed, as well as use of the ASME code case N883 by future licensees, and how the Advanced Reactor Construction Oversight Program will be applied to all new nuclear reactor construction. As our poll question indicates, there are a number of opportunities to enhance the supply chain. If you haven't voted yet, text your answer in. And looking at our poll results, the overwhelming winner at this time looks like limited manufacturing capacity. And that is certainly an area where I know the Department of Energy has been working with entities in all aspects of the supply chain to try to begin addressing some of those challenges. Which challenge is the most significant in the supply chain is also likely influenced by your role as it relates to new reactor build. Our panel today reflects the spectrum of those views, and each brings their expert insights on the evolving supply chain landscape for materials and components essential to the construction of new nuclear reactors. With that, we'll move to our presentations. Our first speaker today is Mr. Matthew Vasquez. Mr. Vasquez is currently ASME's Senior Director of Standards and Certification. Matt has been with ASME for over 17 years. In this role, Matt oversees all aspects of ASME's standards development and conformity assessment activities for over 6,900 certificate holders worldwide. Matt started at ASME in the Nuclear Standards Department and oversaw ASME's Boiler Pressure Vessel Code Section 3 Committee Rules for Construction of Nuclear Components. Matt has a Bachelor's of Science in Mechanical Engineering from the George Washington University. With that, please welcome Matt.
Thank you, Michelle. Thank you to the NRC staff for inviting me to present. Today, I'm going to cover and discuss how standards, certification, and suppliers' readiness strengthen the nuclear supply chain and advanced reactors. The nuclear supply chain plays a pivotal role in ensuring the safe deployment and long-term operational integrity of advanced reactors. As the nuclear industry evolves, it incorporates innovative technologies and meets the increasing energy demand. The need for a resilient, well-qualified supply chain becomes more critical. Advanced reactor designs often rely on complex components, specialized materials that must be manufactured and inspected to standards. The performance and reliabilities of the reactors are directly tied to the robustness of the supply chain network that support them. This not only includes the first tier supply chain, but it broadens past that, tier 2, tier 3, and the balance of plant. Regulators and industry stakeholders share a collective responsibility to foster a supply chain culture that prioritizes quality, safety, predictability. This involves a clear communication pathway, harmonized technical expectations communicated through universally recognized standards, and a commitment to the ongoing education within the workforce. Throughout our comprehensive standard certification programs, ASME provides the foundation to support these enhancements, the safety and the reliability of a global nuclear supply chain, ultimately helping achieve the broader engineering, energy, and safe objectives. ASME standards serve as a backbone of consistent technical practices across the nuclear industry, ensuring that every design, fabrication, inspection, and operational activities adhere to the rigorous establishment of safety and performance benchmarks. These standards, integrated into regulatory frameworks, such as those enforced by the NRC, help create a common language that engineers, manufacturers, and inspectors can rely on globally. The standards support innovation by including new material, design methodologies, manufacturing techniques, and they reinforce risk-informed and performance-based approaches that optimize safety without restricting technological progress. Developed through a consensus process by our international experts, ASME standards offer a practical and reflects the real-world experience. This broad input ensures that comprehensive guidelines meet industry needs for safety, reliability, efficiencies, while harmonizing expectations across diverse regulatory and operational environments. By maintaining up-to-date and global recognition of standards, ASME supports a capable, consistent, and high-performing nuclear supply chain. Certification transforms written standards into tangible, verifiable actions by organizations obligated to demonstrate their ability to consistently meet specific quality requirements. ASME conformity assessment programs involve rigorous audits and assessments that verify suppliers' adherence to a defined quality system. This includes verification of documented procedures, personnel qualifications, inspection methods, test procedures, and qualification assurance protocols. Through these certifications, suppliers not only demonstrate compliance with industry expectations, but they also strengthen the trust of regulators and purchasers. By reducing duplicate oversight and providing clarity in supplier capability, ASME certification contributes significantly to reliability of the nuclear supply chain. The framework ensures that certification entitles maintain a continuous focus on quality improvement, accountability, therefore by overall safety and reducing the risk of project delays. This systematic approach enables regulators and plant owners to better assess suppliers' readiness and ensure that the components and systems are manufactured in accordance with the highest standard and safety and performance. The nuclear industry is experiencing a growing pressure to expand the supply chain capability in order to support the advanced reactor deployment. However, significant challenges exist beyond the traditional Tier 1 suppliers. Tier 2 and Tier 3 suppliers, as well as manufacturers for the balance of plant components, often lack experience with rigorous nuclear quality requirements. Many potential suppliers who possess the technical capabilities may be discouraged by the extensive documentation, inspection, and quality assurance obligations associated with nuclear work. This contributes to a supply bottleneck. Moreover, decades of reduced domestic nuclear manufacturing has diminished, and the number of qualified suppliers creating a vulnerability within the key component sectors. Addressing these gaps require both flexibility and a graded pathway that maintains safety and reliability while reducing unnecessary barriers. The development of supplemental programs, such as ASME's Quality Program for Suppliers, QPS, helps lower entry thresholds for qualification organizations by enabling a structured progress into a nuclear-grade expectations. These initiatives support the diversification and reinforcement of the supply chain necessary for a timely and safe reactor deployment. ASME's Quality Program for Suppliers is designed as a supplemental certification pathway intended to support organizations that supply products and services to general industry. Those who wish to expand into the nuclear sector. Unlike traditional nuclear certification, QPS does not replace the existing nuclear qualification assurance requirements. Instead, it provides a foundational quality program elements that help suppliers establish essential controls across their processes. The QPS standard and its certification process enhance the quality of items supplied by assuring that suppliers meet verified requirements through a structured two-stage auditing process. This includes a document review to evaluate quality manuals and procedures, followed by implementation review to verify conformance to its actual operations. QPS is particularly well suited for those Tier 2 and Tier 3 suppliers, which are segments of the critical to the nuclear deployment, yet historically underserved by the nuclear-specific certification framework. QPS strengthens the nuclear supply chain by establishing auditable and essential requirements that provide a structured entry point for suppliers within the new nuclear applications. QPS helps prepare companies for advanced reactor certification by instilling a core quality principles such as document control, process consistency, personnel competency, and continuous improvement, all of which are necessary for the evolving full nuclear QA framework. This graded approach supports the risk-informed regulatory strategies by establishing the foundation quality is established where it's most needed. By broadening the pool of qualified suppliers while maintaining the rigorous standards, QPS mitigates supply chain bottlenecks while reducing procurement unnecessarily and enhances quality assurance throughout the component lifecycle. As a result, QPS is positioned to contribute meaningfully to strengthen the supply chain required to support timely deployment of advanced reactors. ASME's learning and development programs plays also a pivotal role in building the human capacity required for a strong nuclear supply chain. Throughout its comprehensive courses, such as the ASME BPVC or NQA1 or other life cycles. These programs are online, they're in person, they're team-based. They enable a broad accessibilities across suppliers. These courses often address design rules, fabrication practices, inspection techniques, maintenance requirements, and safety fundamentals, ensuring that attendees both understand the intent and application of the standard. This improves suppliers' capabilities while reducing the risk of misinterpretation or quality lapses. A new supplier entering the nuclear market and ongoing education becomes even more critical to ensure consistency understanding its expectations. Ultimately, workforce competency forms as a cornerstone for nuclear safety, making ASME learning and development a vital part to build a reliable supply chain. In closing, achieving a resilient, scalable, and global nuclear supply chain requires active collaborations across regulators, industry stakeholders, standards bodies, and suppliers. ASME serves as a bridge between regulatory intent and practical implementation by maintaining clear, rigorous, and adaptable standards and certification systems that can be relied on worldwide. Efforts such as QPS, along with other robust standards and comprehensive training programs, demonstrates ASME's commitment to enabling innovation while safeguarding quality and safety. This collaboration environment helps create a harmonized expectations that reduce uncertainty for suppliers and improve regulatory outcome. By investing in a shared solution today, whether it's expanding suppliers' qualification pathways, enhancing technical education, or sustained alignment between industry and regulators, the nuclear sector builds the foundation for a safer and more efficient deployment of advanced reactors. Strengthening these critical links ensure that the industry can meet the future energy needs while upholding its uncompromising commitment to safety and public trust. With that, thank you very much.
Thank you, Mr. Vasquez. Our next speaker is Mr. Raj Jolly. Mr. Jolly is the Manager of Quality for Bechtel Nuclear Security and Environmental Global Business Unit. In his role, he provides management and leadership of commercial nuclear, defense, and space, and environmental and security quality programs essential to successful project execution, driving customer satisfaction and delivering successful outcomes for the company, and the country. Raj has over 33 years of experience with Bechtel, having started in engineering on fossil and nuclear power projects before joining the quality function. He has held lead quality management roles on some of Bechtel's largest and most complex commercial and government nuclear projects, both international and domestic, including Vogtle Units 3 and 4 completion, Waffa Nuclear Power Plant in the UK, and Hanford's tank waste treatment and immobilization plant, as well as leadership roles on key industry committees related to quality contractor assurance systems, procurement, and supplier quality management. Raj is a member of the ASME NQA Standards Committee and Executive Committee, current chair of the ASME NQA Subcommittee on Engineering and Procurement Processes, co-vice chair of the ASME NQA Subcommittee on International Activities, and member of the FCOG Contractor Assurance Systems Task Team. Raj was elected as a Bechtel Distinguished Technical Specialist in 2019 and as a Bechtel Fellow in 2022. Please join me in welcoming Mr. Jolly.
Make sure I don't fall off the stage here. All right, good afternoon, everyone. Michelle, thank you for the introduction, and I'd also like to thank the NRC staff for the invitation for Bechtel to participate in the RIC this year and participate on this panel discussion with my esteemed colleagues here. It's an honor for me to be here today representing my company, Bechtel, and I'm excited to share with you some thoughts on strengthening the nuclear supply chain from an EPC contractor's perspective and based on our recent experience with our nuclear new builds. Okay. So I'd like to first start with a brief background on Bechtel and a summary of our long history in the nuclear industry. Some of you are already probably quite familiar with our company, Bechtel, and the fact that we've had a significant presence in the industry for many decades. But many of us have also seen over the last few years especially, there are some new players in the industry now, and there are some that may not be as familiar. So I'd like to share a little bit about our company with you. But I'd like to spend most of my time sharing some of our recent experience from our new nuclear builds, some of our key considerations and actions that we're taking to strengthen our supply chain ourselves and the industry overall. Now, since this panel is about strengthening the nuclear supply chain, I'd like to share that this is not just about our suppliers and subcontractors, and it's not lost on us that we, folks like Bechtel, are part of the nuclear supply chain as well, especially when it comes to NRC licensees, reactor technology providers, and other key stakeholders to us. So while I also came with some considerations for our supply chain, I also came with some considerations for Bechtel ourselves and not just our supply chain. So a little bit of background on our company. Bechtel is in its 128th year of business, starting out in the late 1800s with constructing railroads. Since then, we've grown into one of the largest engineering and construction firms in the world, executing projects across 5 global business units, and we've delivered some of the largest and most complex projects around the world across many industries, also including nuclear. Now, it's really hard to condense all of that 128-year history on a slide. So here, I've just covered some of the highlights. Our origins in nuclear actually go all the way back to the Manhattan Project era, the legacy it left behind, and it spans virtually the entire history of the commercial nuclear power timeline, all the way up to today with our new builds. With over 70 years of experience, having built the first ever commercial nuclear power reactor, having designed, constructed, or serviced over 80% of the US fleet and over 150 plants worldwide, I think it's pretty safe to say that nuclear is Bechtel's sweet spot as a company and has given us some deep experience in nuclear EPC delivery. There we go. Now, all of that history is great, but we've heard earlier today, we heard at last year's RIC, and we've heard for the last several RICs over the last few years that, and I think we can all agree that we've entered a new era in nuclear in many ways, and we all as an industry have many challenges that we need to address. Those of you that attended these technical sessions at last year's RIC, you may remember one in particular where there was a very sobering message about what that was shared at that session last year on what the energy demand is projected to be in the future, whether you want to talk about 2035, 2050, et cetera. How many new nuclear power plants will need to be built to support that demand, and what the size of the supply chain and workforce will be required to deliver all of that. Through those challenges, we also have opportunities to not only strengthen the key areas vital to the success of the nuclear power industry, but also to set it up for long-term success. Some of the more recent nuclear power project experience that underpins what Bechtel sees in the way of challenges comes from the following projects that I'll just touch on just very briefly for the next couple of minutes or so. First is Vogtle 3 and 4. You heard a little bit about that this morning, which Bechtel completed in 2024 and continues to perform very well today. We were not the first contractor that tried to deliver that project, and we stepped in where others could not complete it, and we helped it across the finish line. Through the Vogtle project, we collected many lessons learned, and when you combine those lessons learned with our nuclear and other mega project experience in other industries, like our significant presence currently in the Gulf Coast where we're delivering 4 LNG projects simultaneously, we're placed very well to do our part to help the nuclear industry. Bechtel currently has 3 other active nuclear power plant construction projects that are all in various stages of their life cycle. First is the project in Poland where Bechtel and Westinghouse are working together to deliver 3 AP1000 units. So my partner Sean is on the panel today helping to deliver that project. This is Poland's first nuclear power plant, and it brings with it many challenges, including working with new suppliers that have never done this before in this kind of environment. We've been quite active in bolstering the Polish supply chain and Polish industry overall to support this project, and we actually just completed our 9th supplier engagement workshop in Poland with over 100 new suppliers in attendance. The project is progressing well with subsurface investigation, early design, and construction planning in process, and we actually recently placed the order for the steam turbine and generator as well for that project. So that project is making very good progress. We're also executing the Natrium demonstration project in Wyoming, also known as Kemmerer Unit 1. Design and construction planning are in process, and we had a groundbreaking and site mobilization in 2024, and with construction underway on their test and fill facility and training center, with wider construction mobilization planned for the middle of this year. And finally, the Clinch River site in Oak Ridge, Tennessee. Bechtel had, for that project, Bechtel had previously supported TVA with its early site permit application to the NRC, and TVA has hired Bechtel to be its construction partner for that project, and it's in the early stages of execution. So through that project experience, going back to Vogtle and Natrium, Poland AP1000, and early days with the Clinch River Small Modular Reactor Project, what are we seeing in the way of challenges, and what are some of the impacts? And I think you're probably going to hear fairly consistent messages across the panel today. We're seeing a diminished safety-related commodity supplier base. We're seeing supply chain capacity issues, and not just with safety-related equipment, it's across the board safety and non-safety related. For example, pipe spool fabrication, approximately 80% of the U.S. capacity is currently being utilized. For valves, over 75% of global capacity is being utilized. Steel fabrication, over 70% of U.S. capacity is currently being utilized. And reinforcing steel, over 80% of U.S. capacity is currently being utilized. We're seeing long lead times with critical pieces of equipment. For example, pumps, we're seeing lead times of up to 130 weeks. Electrical equipment and switchgear, over 200 weeks in some cases. The domestic supply chain capability for certain key commodities just isn't there. For example, in the U.S., we primarily look to Japan, Korea, and India for fabrication of large reactor components. The supplier's ability to control their sub-tier suppliers has been a challenge, especially the deeper that their supply chains go. And a relatively unexpected one, and this one kind of hit us out of nowhere in our company, and it's possible others might be seeing it too. It's a very non-technical thing. It's alignment on commercial terms and conditions that used to work between us and our suppliers and our supply chain, and now all of a sudden they don't really work so well. So what are all of these causing? So these have all resulted in delays in placing orders in some cases, and fabrication and delivery delays, which obviously will be impacting our delivery schedules on those projects. Whether you want to call it an issue, sorry, I didn't want to go back to that slide yet. Oh my goodness. Okay, I'll just leave it there. Okay, there we go. Okay. An area of continued focus for us, despite those challenges, but we know it's something that we have to focus on, especially with the diminished supply chain and new players in the industry, is our focus on ensuring maintenance of a healthy nuclear safety culture. Now, I think we all know what that means and what the definition of that is, and we actually have policies in our company at Bechtel that require a positive nuclear safety culture to be established and maintained on all of our nuclear projects and across functions performing nuclear regulated activities. On our end as an EPC contractor, some of the challenges that we're seeing include, obviously this should be no secret to anybody, the reduction of a skilled workforce in nuclear across all functions and with craft labor. Take, for example, a large 2-unit project, nuclear project, where it takes approximately 800 to 900 field professional staff to execute that project, approximately 2,400 craft professionals on average, with peaks exceeding, in some cases at times on the project, over 4,000. Excuse me. Shortages of electricians, welders, and pipe fitters exist. And in fact, the projected shortage of electricians is viewed as the critical craft constraint on U.S. nuclear projects. We've experienced a reduction in our approved suppliers list of safety-related suppliers and subcontractors. Something I think was touched on a little bit in the previous session just after lunch today. We have a tendency as an industry to historically tended to specify custom solutions from our suppliers versus designing around building what they make. So that's something, in full transparency, that's something we struggle with at Bechtel as well. We're starting to turn the corner with shifting that mindset to buying more what suppliers make and not making the suppliers do something special for us, for every single site, which may be hard for them to execute and add to the delays that our projects are seeing. We've had our own challenges with visibility and control of our supply chains and our sub-tier suppliers, especially as the supply chains go pretty deep. Projects pulling on lessons learned and pushing them back out to help other projects has also been an issue, and regardless of if it's an issue or not, it's a concern, and it's definitely a key focus area of ours. Fostering and maintaining a healthy nuclear safety culture is something that we focus on in our company on every single nuclear project. And as a matter of fact, many of our most seasoned nuclear project managers at Bechtel have shared throughout the company and in pockets of the industry that ensuring a healthy nuclear safety and quality culture is paramount to having a successful project and successful delivery to our customers. And without those things, the projects are just not as successful. Come on now. There we go. So what is Bechtel doing about all of that from a supply chain perspective and for ourselves as from an EPC contractor perspective? Well, we're doing many things, both from short-term, tactical, and strategic long-term perspectives. When it comes to addressing our supply chain, some key actions that we're taking are having increased and more deliberate engagement with our suppliers, understanding their processes and their challenges, and helping them understand our perspective in what nuclear project execution is like and it's all about. development and use of actionable metrics around supplier activities leading to acceptable receipt at the job site, or in other words, did we get what we asked for? Working with and guiding new suppliers on development of their nuclear QA programs, and in some cases obtaining ASME and certificates of authorization, and growing the qualified and capable supplier base. Reevaluating our standard commercial terms and conditions and helping our suppliers better understand them, and understanding that it's not just a given anymore like it used to be in the past. And continuing our emphasis with our suppliers on the importance of nuclear safety culture and quality excellence. One of the most important actions that we're taking at Bechtel, however, is that we are sustaining our supply chain networks and capabilities through the procurements we handle across all of our businesses. If you think back to the earlier slide, they gave the snapshot of our 5 global business units and all of our businesses across the entire enterprise. And with many of our projects being of the scale of a nuclear project and even larger mega projects. Here you can get a sense of the scale that we deal with as a company, and it shows that we are not afraid to deal with complexity or volume, that we're well positioned to leverage our market intelligence, and that we're invested in the success of our supply chains. And through all of this, we're making a conscious effort to ensure that we stay tuned up to be ready to deliver our new nuclear projects. When it comes to our concerns and challenges as far as our delivery of new nuclear projects, as far as that's concerned, some key actions we're taking at Bechtel include continuing our deliberate focus on robust maintenance of our nuclear QA programs and nuclear certifications, implementing nuclear training programs using a tiered format covering all levels from top to bottom of our organization, continuing to be the largest employer of building trades in the U.S., which we are, and having craft maintain their proficiency on our other large projects while we still partner with local colleges and trade schools to develop talent pipelines near our projects, and working with labor unions to bolster their apprenticeship programs. Restocking our approved suppliers list for safety-related commodities, enhancing our own supply chain mapping, standing up digital delivery tools that are approved for use on nuclear projects to go paperless in the field and improve productivity and efficiency, and which are already in use on our other large projects. Increasing our focus on ensuring our lessons learned program internally is effective, having a more deliberate focus on our employees in very specific ways around employee retention, employee development, and talent identification within our company, and continuing to drive internally our emphasis on the importance of nuclear safety culture and quality excellence. So while I'm sure we have a lot to discuss on this topic, and we can go on for days and days and days probably, in the interest of time, let me just close with a few key takeaways from our EPC contractor perspective. Collaboration with the supply chain to align on understanding of risks, capacity, capabilities, challenges, and actions needed is crucial. We have to continue the focus on personnel development and readiness to execute nuclear projects in a very deliberate fashion and in ways that we may not have done for quite some time. It's critical that we stay diligent on ensuring that our past lessons learned have in fact been learned. And we also have to continue to understand and stay committed to maintaining a strong nuclear safety culture as an industry imperative. And final thought, it's also important to realize that the challenges facing us are not insurmountable. Just look around this room, which might be hard to do because the lights are low, but the spotlight is right on me. There are hundreds, if not thousands of years of experience in this room, just this room alone. We should be able to do this. When it comes to my company, Bechtel, we have generations of experience. I'm a prime example as a second-generation Bechtel employee who's working in nuclear. My father did the same thing for the first generation of nuclear power plants that we constructed. We have the people. Again, we're the largest employer of the building trades in the U.S. We have people ready, and we're working really hard to get other people ready as well. We have key industry and supply chain relationships. And finally, we have a long history of nuclear EPC and other mega project delivery to rely on. So with that, I'll close. Thank you for your time and attention, and it's been an honor to be here with you today. Thank you.
Thank you, Mr. Jolly. Our next speaker is Mr. Hyun-Soo Kim, Mr. Kim is director of the Pittsburgh office at Doosan Enerbility. Since joining Doosan in 2010, he has built a distinguished career in the global nuclear power industry. As a member of the U.S. AP1000 project management team, he contributed to the supply of first-of-a-kind AP1000 major components, including the reactor pressure vessel and steam generator. He later moved to the UAE Baraka Nuclear Power Plant project management team, supporting the successful delivery of nuclear steam supply system for one of the world's largest nuclear construction projects. He then moved to the overseas sales and marketing team, expanding Doosan's reach across major global nuclear markets. Initially, he was engaged in a wide range of global sales activities involving major components, instrumentation and control, and services. Later, his focus shifted to business development for small modular reactors, where he contributed to enabling equity investment and building strategic partnerships with SMR developers. Since 2024, as director of the Pittsburgh office, Mr. Kim has been actively involved in business development and sales in the North American market. In this role, he continues to support Doosan's presence and partnerships in the region through dedicated service and collaboration. Please join me in welcoming Mr. Kim.
Thank you, Michelle, for that kind introduction. AI wrote that description for me. Good afternoon. My name is Hyun-Soo Kim, working at Pittsburgh office of Doosan Enerbility. I started my career at Doosan Enerbility on the United States AP1000 project, and also I engaged a lot of U.S. Nuclear businesses, including SMRs. So it's my true honor to be invited as a speaker at NRCgov event to share Doosan Enerbility's effort and collaboration in United States nuclear business with the distinguished guests. Today, I would like to begin with the brief introduction to Doosan Enerbility, followed by an overview of Doosan SMRs and large nuclear business. Let me first mention about the name of the Doosan Enerbility. 4 years ago, Doosan rebranded it ourselves, changing our name from Doosan Heavy Industry and Construction to Doosan Enerbility. The term Enerbility combines energy and sustainability, reflecting our commitment to developing clean energy solutions and contributing to sustainable future. Doosan Enerbility's business portfolio is evolving. While we continue to strengthen our existing businesses, such as large-scale nuclear power, we are actively expanding into next-generation reactors, such as SMR, gas and hydrogen turbines, and wind power solutions. We are also investigating in digital solutions, additive manufacturing, and circular economy initiatives to drive future growth. There are 4 business groups. Doosan Enerbility operates through 4 major business groups. The first is Nuclear Busy, which I came from. And Nuclear Business Group manages nuclear component manufacturing and services, as well as casting and forging operations. The second is EPC-BG, specializing in engineering, procurement, and construction for power plants, including nuclear plants. The third one is Power Service Business Group, which provides turbines, generators, and boilers, along with the plant operation, repair, maintenance service solutions. The last one is the brand new one. This year, Doosan make that wind power business group because of the Korean government. So wind power business group provides wind turbines, generators, along with services. Now, let me introduce Doosan Enerbility's nuclear businesses in more detail. This photo is bird's eye view. This is Doosan Enerbility's manufacturing facility located in the Changwon, South Korea, the very south part of the Korea near to the Busan. The total area is 4.5 square kilometers, which is equivalent to about slightly more than 600 soccer fields. With this manufacturing facility, Doosan provides an integrated solution that covers the entire processes from a raw material production to a final assembly of components for nuclear power plants. This is portfolio. Since the early 1980s, Doosan has been manufacturing and supplying major components for large-scale nuclear power plants, such as reactor vessels and steam generators, for more than 40 years. In addition, Doosan provides a wide range of solutions to customers with its capability in auxiliary equipment, I&C, and service businesses. For United States nuclear businesses, Doosan has been mainly focusing on the most difficult part of manufacturing, which are reactor vessels and steam generators. These major nuclear components are crucial for the timely construction of nuclear power plants. Let me explain in more detail about how Doosan manufactures reactor vessel and steam generator. The manufacturing processes of major nuclear components begins with the production of material at Doosan's casting and forging shop, the first photo. And after making an ingot and forging material at Doosan's forging shop, these materials are moved to the turbine shop or nuclear shop for the machining, welding, and assembling and testing work at Doosan's nuclear manufacturing shop to produce the final products. The completed product components can be shipped directly globally through the Doosan's own dedicated port, very near to the Doosan dock. So that is for the final picture, right-hand side. This integrated, non-stop solution for manufacturing is a unique strength of Doosan. Now, let me walk you through Doosan's SMR business, and then I will cover the large nuclear businesses. I believe everyone knows about SMR, and governments in major countries, including United States, are actively supporting technology development and licensing development and construction efforts to commercialize their domestic SMR modules as quickly as possible. In this environment, Doosan and Ability developed a strategy to be global #1 SMR foundry with its advanced manufacturing capability for large-scale nuclear components. Utilizing its accumulated expertise, Doosan plays a role of realizing customers' design into actual products, similar to the role of the TSMC and Samsung serves in the semiconductor industry. That foundry came from the semiconductor businesses as well. So let me elaborate on what's the SMR foundry. Doosan is not waiting for the final design or purchase order from the SMR developers. Doosan aims to go beyond the role of the simple manufacturer that merely fabricate equipment based on the customer's design. Rather, Doosan actively participates from the early stage of the SMR development to enhance the completeness of SMR design in terms of manufacturability. So far, Doosan has built strong partnership with the leading SMR developers in the United States. We have conducted a lot of manufacturability reviews, lots of mock-up tests, and other essential activities to secure the highest manufacturability. By engaging from the early stages, Doosan is playing a key role in success of various SMR designs. So that's different from the typical yesterday's supply chain activities. Now, let me tell you about the large nuclear power plant businesses. The reason why Doosan has been able to successfully support SMR developers is because of its previous experience with the first-of-the-kind AP1000 project. Someone might ask Doosan or me, what's so difficult about manufacturing products with very similar shapes, So old reactor seems like a most likely AP1000 reactor vessel and steam generator. However, the challenges, real challenges, are often hidden in the small details. Doosan and Westinghouse have made tremendous effort to successfully manufacture first-of-a-kind AP1000 major component more than 10 years ago. That was delivered from 2012 to the 2017 timeframe. So I can say it more than 10 years ago. And with that collaborations and very huge effort to overcome many unexpected situations. So devils live in detail. So something happened with very, very detailed thing, it seems to be nothing, but it's very something. So we overcome that, and finally, Doosan successfully supplied 6 reactor vessels, 12 steam generators, and 2 reactor vessel internal to United States and China AP1000 projects. This first-of-a-kind manufacturing experience has enabled Doosan to develop a culture of delivering benefits to customers by proactively ensuring a high level of manufacturability. This slide shows some photos for the replacement project to supply to United States market as well. And those are reactor vessel head for the replacement project in United States so far. So until now, Doosan delivered total 34 reactor vessels and 124 steam generator globally, including 4 reactor vessels and 24 steam generator to United States market. So let me conclude my presentation. Doosan N-ability has accumulated experience in the manufacturing and construction of nuclear power plant, and the United States has strong foundation in nuclear technology, licensing, development, and expertise. So I firmly believe that by combining the strength of both sides, we can maximize opportunities to accelerate the transition toward a sustainable future in the clean energy market. Doosan will make every effort to underpin a success of first-of-a-kind SMR in the United States and first in the world, AP1000 in the United States in a soon time. Thank you very much for kind attention.
Thank you, Mr. Kim. Our next speaker is Mr. Sean Jones. Mr. Jones is Vice President of APX Supply Chain at Westinghouse Electric Company, where he directs global supply chain and procurement strategy for AP1000 pressurized water reactor projects and advanced reactor technologies. He oversees supplier strategy, commercial execution, and delivery performance for large-scale nuclear new build programs worldwide. With more than 20 years of experience across the nuclear and aviation industries, Mr. Jones has held multiple leadership roles within Westinghouse's global supply chain organization, driving AP1000 supplier performance, international procurement, and the delivery of major engineered equipment valued at over $10 billion across the United States, China, and Europe. Before joining Westinghouse, he led programs at Curtiss-Wright Corporation supporting the manufacturing and delivery of AP1000 reactor coolant pumps after beginning his career as a mechanical engineer. Mr. Jones is also a U.S. Marine Corps veteran, having served as a helicopter mechanic, experience that shaped his disciplined, execution-focused leadership style. He holds a Bachelor of Science in Mechanical Engineering and a Master's of Business Administration from the University of Pittsburgh. Please join me in welcoming Mr. Jones.
Thank you, Michelle, and thank you to the NRC for having me here today and having Westinghouse speak on something that we're very passionate about. We have a number of opportunities throughout the globe to really be focusing on delivering excellence to our customers, and that can't be possible without having a resilient supply chain, right? You know, when we think about resiliency, when we think about what the nuclear industry is looking to transform into, and what we have already paved the way for, the things that we look at are things such as partnering. Many of us on a day-to-day basis can be competitors, and on the next day we're collaborators, right? Within the nuclear industry, when there is an issue, we all come together. So we need to be focused on that collaborating mindset if we're going to meet the energy needs and that energy independence that we strive to as we build those reactors for tomorrow. We need to focus on a buy where we build strategy, not only because that's the right thing to do for the local economies that you're building in, but that's the right thing to do if you're trying to have a resilient supply chain. You need to be focused in global, regional, and local suppliers, making sure that you have a robust and resilient approach to being able to deliver on the reactors that you're committing to and being able to partner with those suppliers to do so. What we need to drive to in the nuclear industry is that predictive delivery, on time, on budget, and on quality. The nuclear industry has a reputation of being over budget and late. We have to change that reputation, and it starts with the supply base. We have to work together, we have to drive that sentiment, and we have to drive to that predictive delivery. We need to show that it's not only focused on cost, it's not only focused on schedule, but it's also focused on quality, first time right. It does the constructor, it does Bechtel, it does no constructor any good if we deliver something on time and it's not right. They don't have time to quarantine things. They're trying to get things built, right? And why is this absolutely critical to what we do? What we do in the nuclear industry is critical. It's complex, but it requires the continuity, time and time again. So when we look at things such as how do you strengthen that nuclear supply chain, it starts with having a robust design, right? The AP1000 is a completed design. It's been built 6 times. It's operating across the globe and setting capacity factor records wherever it's operating. That is important because now all those design engineers have the ability to focus on the supply base and the supply base development. How are we going to focus on continuous improvement, right? We're not focused on turning out the next design drawing, fixing something that the fabricator found as they were fabricating a brand new design. We have a design that is fully manufacturable, has been manufactured, and we're ready to replicate that. That goes into being able to strengthen the existing supply base through focused on improvements and an improvement mentality, which is what we do in the nuclear industry, but also expanding that supply base. We've already developed 6 Polish suppliers in large structures manufacturing. We've already qualified them to NQA1 through a phased approach. They're now in their technical development phase, and we're going to get into the mock-up phases here within the next several weeks with many of them. We're doing the same thing in the US. There's a number of fabricators that are new to the nuclear industry that are developing mock-ups today to be able to support the new AP1000 builds. Why? Because we have to continue to expand that supply chain. We need to make sure that we're focusing on strategic partnerships. We're not going to build PowerPoints or power plants in a courtroom, right? We have to focus on partnering, right? We have to focus on being predictive instead of reactive, right? We have to be able to look forward of what's going to happen and be able to be predictive and understanding not only what's at the tier 1 level, but the tier 2 and tier 3, because that's usually what strangles the supply chain. It's not the tier 1. We all have that mapped. We have that memorized. It's the tier 2 and the tier 3 suppliers that get you. You could have 7 different valve suppliers for the same valve, right? But if they all go to the same casting vendor, you still have sole source in your supply chain, right? Making sure that we standardize and simplify that design so that it's repeatable. Making sure that we're repeating the same thing over and over again, designing, manufacturing 12 steam generators, right? Manufacturing the same CA20 submodules, because we're going to continue to get better, the costs are going to go down, the efficiency is going to go up, right? We need to ensure when we go into those new suppliers that the focus has to be the culture. And we heard Matt say it. I heard the earlier this morning with the directors of the NRC talk about nuclear is boring. They want it to be boring, right? Because we need to be focused on repeatability, focused on that culture of That has to be first time right. We have to make sure that our number one focus is safety to the public. And then lastly, we have to develop that talent, right? One of the things that we look at, and when you did that poll up there, it was interesting, right? You said the biggest concern was the manufacturing capacity. Well, if we unpack that, what causes that? Long lead times, inexperienced or aging workforce, making sure that you have that regulatory compliance that meets the NQA1, that meets the ASME Section 3, that meets ISO 9001 or 19443, having limited qualified suppliers, right? Those are the things that drive the manufacturing capacity. To me, it's not really the steel buildings that are sitting there that are really the driver of the manufacturing capacity. To me, it's the qualifications, it's the culture, and it's the people. We have to be ensuring that we're able to do a generational baton pass. We have an aging industry. We have to bring new people in. We have to get into the secondary schools, the high schools, the colleges, and drive that interest into nuclear. Nuclear is a high-paying, high-skilled job throughout various different, even if it's a pipe fitter, an electrician, an engineer, or a finance person working in this nuclear industry. It's a well-sustained, high-paying job. We need to expand that qualified supply base. We need to find and make sure that they understand the regulatory compliance and that culture is there, right? And then being able to have something that's a repeatable, completed design that you're building the same thing over and over and over again is going to drive down those lead times. Having that qualified supply base is going to drive down those lead times. But other things that we need to focus on is what other technologies are out there. It's not always about producing more labor hours. It's about serving more clients. How can we serve more clients through additive manufacturing, through robotics and welding? It's not about replacing welders. It's about extending their lifetimes as welders through robotics and additive manufacturing and other technologies so that we can get more production out of a smaller workforce, right? So we look at addressing these challenges from visibility, right? We need to be looking at that beyond that tier 1, like I said, tier 2, tier 3, right? Where are the strangle points in your supply chain? We need to partner with our suppliers to understand what it is in theirs so that we can work together to solve those problems, understanding what opportunities we have and what we can address in those gaps. Flexibility. You need to be adapted and stay ahead. You need to make sure that you have the ability to move from terms and conditions, as Raj pointed out, or supplier capacity issues or raw material supply. What are your flexibility options? Redundancy, backup suppliers, and I Doosan, I would love to be a sole source supplier, right? But I have to have backups, right? They can't build everything. They're a very trusted and strategic partner for us, but they can't build everything. So we have to have redundancy. It's not something that's optional. It's strategic, right? You have to make sure that you have that. And then collaboration. And I've said it 10 times already, but I'll say it again. It's partners. We're creating partnerships. They're not just a supplier. They're a partner in everything that we do, making sure that we're both making each other better every day. So we focus on those people, the training, the new generation, collaboration with universities and secondary schools. There's a significant amount of internships and development that we have within Westinghouse, and we turn a lot of those interns into new hires, and we train them in what we call the Westinghouse way, right? We want to train them up into working, thinking, and doing the way Westinghouse does business so that we're creating a new culture and a new generation of people that will run this nuclear industry as the AP1000s are continuing to run for that 100-year lifespan, way beyond any of us in this room that are still here. Process, we need those new technologies I talked about, right? The additive manufacturing, robotic welding, and so forth. Redundant sourcing, having the backups, and the partnerships, making sure that we understand what drives success for both the supplier and for us. Because if it's a win-lose scenario, both of you are not going to be happy in the end. When we create win-win partnerships, we're both happy delivering to our clients and making our clients happy. Right? We have to drive that mentality of on-time delivery, meaning predictive delivery. On time, on budget, on quality. Right? And when you think about the strengthening or the resiliency, it's not about bouncing back from failure. It's about being prepared. It's about predicting what's coming. And we're able to drive that predictive supply chain through the visibility, the flexibility, the redundancy, and the collaboration, making sure that we have a supply base that is not only used to building, that has built, that continues to build, but every day expanding that supply base so that we continue to grow and develop new suppliers to expand that nuclear fabrication capacity. With that, thank you very much, and I'll turn it over.
Thank you, Mr. Jones. Our next speaker is Mr. Masoud Usman, currently the Chief Nuclear Construction Officer at Fermi America. Mr. Usman is spearheading the nuclear component of a first-of-its-kind 11-gigawatt private energy campus in Texas, a project that includes 4 advanced AP1000 reactors and 4 SMRs planned for delivery on a schedule and on budget. He has a proven track record of guiding complex, high-stakes nuclear projects from concept through commissioning, navigating stringent regulatory environments, and aligning diverse international stakeholders to achieve results. Mr. Usman has played senior leadership roles in the successful deployment of 16 nuclear reactors worldwide, including Westinghouse AP1000 new build projects in China and the 4-unit Barakah nuclear energy plant in the UAE. Worked in Europe, China, and the UAE, he excels at building collaboration among global teams and partners to drive projects to completion. His career reflects technical excellence, execution success, and the credibility of delivering transformative nuclear energy projects. Please join me in welcoming Mr. Usman.
Thank you very much, Michelle. There was a introduction that I think AI, this one, I think our communication team, right? Well, thank you everyone, and thank you NRC having me here and then speak about our project that we are very proud of and our company, Fermi America, and what it is that we are going to do. So as you would notice, I'm kind of different. I'm on the other side of the table from the rest of the speakers on the table. They are on the EPC, manufacturing, design, those aspects. So I'm on the other side. We are building nuclear power plants. And Fermi America is a new company. It's actually a little bit over 1 year old, but we are very ambitious, and we are going to achieve this great project at the heart of Texas, Amarillo, Texas. So let me start with my presentation. So first, what is Fermi America? We are developing this 11 gigawatt campus, and that's going to be behind the meter, private grid for the hyperscalers. As we all know, the AI is booming, and it's going to continue consuming more power for the foreseeable future. And at this time, the AI companies are competing against the regular consumers for receiving the power, which is not beneficial for the power, for the customers. And they cannot compete with these companies. So our approach is a bit different. We are providing this private campus for them, and then this power is behind the meter just for these tenants who are going to be located at our campus. So when we talk about 11 gigawatt, you can think of like state of New York amount of power in an area half the size of Manhattan Island. So our site is pretty large, but still it's a significant technical challenge for placing this amount of power at this location. So we obviously need multiple power sources to achieve this, especially considering the reliability of this power required for the hyperscaler customers. We are aiming triple nines, quadruple nines availability of power. But when it comes to baseload power, nothing can beat nuclear. So with that in mind, we are going to build 4 large AP1000 reactors at our site. And why we are starting with AP1000s is very obvious to us. We are looking for achieving this project in a shortest period of time possible. And that requires us to work on technologies already established. So we do not have time and luxury for trying out new technologies. When we see AP1000, it's been built operational around the world, in China, in the United States. That's a proven technology. And it's already been understood supply chain. What it takes to build an AP1000 is very well known. And our plan is, in fact, copy Vogtle Unit 4 at our location as much as possible. Our license application is around that, and I will talk about that a bit later. At our site, we have space for additional nuclear technologies, specifically SMRs, and we are currently watching the market, looking for which SMR technology is making forward and making some progress, and that will be the one that we will consider at our site, again, since we don't want to be the first of a kind. The site is perfect location for this kind of a project, as it is located at the epicenter of multiple gas pipelines. Why it is important? Because the hyperscalers need the power right now. Even though they prefer receiving the power from green, non-carbon emission sources, they cannot get it right now, as nuclear takes time to build. So our site is providing them with the opportunity for this bridge power coming from gas. Gas turbines are also very difficult to get, so we are lucky for advanced planning that our gas turbines are already arriving to Texas, and they are on their way to our site. In the next few years, we will be adding about 1 gigawatt of power at our campus until we reach to construction completion of the AP1000 units. So regarding the nuclear supply chain crisis, so this is the topic of today's session. So I want to share what we see from this side of the table as an owner organization, what it is that concerning us, and what it is that we are doing to overcome the challenges. First and foremost, if we wait until we sign the EPC contract for placing the long lead items, then it will be too late for us to finish this project on the timeline that we are shooting for. So then long lead items has to be placed in advance. That is one of the big lessons learned before you even sign the EPC. That requires some commercial risk, obviously, as our license application has not been approved yet, but we are very confident as our application has been accepted by the NRC, and we are aiming, copying the last large unit constructed in the United States as much as possible. And we have also confirmation for our site conditions and environmental, thanks to our neighbor, Pantex. Pantex, for those of you familiar, it's the nuclear arsenal, all the nuclear weapons maintenance facility, DOE facility. And Pantex has the environmental data for the last 4+ decades. They have the ground wells. And we already completed hundreds of core borings. So when you eliminate those site-specific variations from Vogtle, and if you just confirm that those are going to be okay, then it is a very low risk for us to go ahead and place the orders for the large components with the very long lead items. And we are calling this as a zero sum, as we are observing that there are about 60 large nuclear power plants projects are either in progress, or near-term start. And all of these companies are utilizing on the Western Front just a few suppliers for these long lead items. So even though I agree with Sean that we need to create some redundancies so then there are different suppliers are also available, at this time, most of them are going to the single location. And even if they are not going to the single location, at one point, the manufacturer of the raw materials are the same. So we are having a lot of single point locations for these important and long lead items. And the only solution then becomes that we have to place the orders as soon as possible. So these are the critical long lead components that we are targeting in Fermi America. These are all the necessary long lead items to build NAP 1000. And it's very important that they are not only need to be delivered in a favorable schedule, but also they need to be delivered in high quality. As AP 1000 being a modular design, is the Lego pieces that we are putting it together, we are establishing a module manufacturing facility at our site in Amarola. And so then all these sub-modules will arrive there for creating the bigger modules for most parts. But when it comes to reactor vessel and steam generators, we have already placed our phase 0 contract. So phase 0 contract is for us starting the clock for the delivery of these components to our site. As these are being one of the longest lead items, we had to start with them. And it's a phase 0 contract because it is up to the point for getting Doosan receiving all the raw material and then ready for the forging. So now, in a very timely manner, we have to place the phase 1 contract for the continuation of the work. But if you look at this list, when it comes to, for example, INC platform, that is one of the longest lead item. So that also requires us to very quickly engage with Westinghouse to start some of the work. Only good part is that this is going to be a repeat work. And when it comes to technology, now there is an AI. We cannot ignore that. It is almost not using calculator for your math class these days. We all have to use AI. And with utilization of the AI, we are experiencing significant improvements in our company. We are very pro using AI. We actually have several engineers, AI engineers, working on creating special agents for our work. And I would recommend everyone to do that and then don't fall behind on that revolution. And with those AI technologies, we are very optimistic that certain items like the INC platform with heavy software development will accelerate. So those timelines will get better. But as a solution, Make America Nuclear Again, we are answering Mr. President's call. We are creating this private campus just for the AI data centers. Similar, we are looking for not to build these units only for us, but for the United States. There is a huge need for getting all these nuclear power plants built in the US, and it's about time for America to take back the leadership in nuclear. So with this, when we originally submit our Title 17 loan application, we introduced a MANA initiative, which in fact asking multiple units procurements all at the same time and working with identified suppliers to not only provide the parts for the Fermi units, but for all the upcoming units, almost paving the road for everyone else. And later, a similar concept was proposed by Westinghouse as well. So now DOE and Westinghouse, there is that concept also there. And we just really support that. That is the idea for us to get this done. Put the items in the queues so then they are keep coming. They are considered as national assets, so they are interchangeable components that if one project fall behind or decide not to proceed, the part can be sent to the other units. And it can also give us start with the immediate actions as long as we've confirm all the financing required for this one, and for Fermi America and State of Texas ready for their part, and now we are waiting to hear from DOE. And as we all understand, volume economics. If we are just placing multiple orders at the same time, it's gonna get better pricing. And this is a partnership, so we cannot achieve this mega goal by ourselves. So we are working with several partner companies. Doosan Enerbility is one of them. Obviously, I mentioned about phase 0 contract being placed with them. We have very good relation with them and following up on those orders. Hyundai ENC, they are in the recent decades, they involve construction of 18 plus nuclear reactors. And I don't remember any time they, end up with any liquidated damages. So it is an unmatched global track record. We are working with them. They are our preferred ENC partner and currently performing a FEED study for our site. And in fact, we have already started our EPC negotiations with them. MVM EGI is an Hungarian company. This is for the cooling. We are located in Amarillo, Texas, and if you don't know the situation there, it is actually a farmland. There are a lot of cornfields around us, and corn is 95% water, 5% God, so it is consuming a lot of water. We are surrounded by over 3,000 pivots. So this circle, maybe you've seen them while you're flying over those areas, the circle fields, they each consume about 2.5 million gallons per day of water. So the water in Amarillo exists, but it is underground. It is the Ogallala Aquifer, which is United States' second largest freshwater and saltwater aquifer. So it is the Rocky Mountains on the western slope goes, and then Hoover Dam is there, and everyone knows. And nobody cares about the eastern slope, but eastern slope goes to Ogallala and then charge that aquifer. However, even though we have water, we are considering this great technology, bring it to the United States with MVM EGI, building these big towers. These are going to be 600 feet tall, huge hyperbolic towers, and it all natural draft with the Heller effect. The first 100 feet of the tower is all air-cooled condensers surrounded by that. And natural draft is getting the water going through those ACCs cooled. Our calculations shows that we can get 2 of these towers, each of the AP1000, to continue with normal weather conditions, no water usage at all. However, we are also placing 16 water-to-water heat exchangers inside each tower for high ambient temperature conditions to initiate a hybrid cooling. That technology exists. It does exist. It's being used other places. We actually visited several such towers, and we have the design ready, and we have the purchase orders ready to proceed with that technology. So this is the site progress in Amarillo, Texas. So it is not about, artist rendition. So this is the actual progress. The work is ongoing. And you can read the numbers about how many feet of roads installed, how many feet of fencing, and then, lands and everything, and water and gas already arrived to the site. I'm not going to go too much on the Vogel 3-4. I think, it was Raj already mentioned about that. yes, that was a very good lesson for all of us, and we learned a lot as an industry. So we are looking for, with that lesson learned, obviously not to repeat none of them, and now we have solutions how we can do this better next time. And for the NRC licensing progress, our combined license application accepted. And all I can say is that if we are getting a permit to start with the construction, we are ready as early as this year to start the construction activities with a license expected in 2027 with the nuclear construction to start. And so this is showing our brief timeline. From 2025 we start, and then we are looking for 2033 for getting the power from the first unit. Again, key takeaways: act now, that is very important. MANA or something similar that Westinghouse and DOE is also working is essential. We need to procure them for everyone in bulk. Proven team, proven design is important. And we are ready to break ground in 2026 this year, as long as DOE, DOC support is there. Thank you very much.
Thank you again to all of our panelists. That was a really fascinating set of presentations and provided a lot of really interesting perspectives on the different issues related to supply chain from across the spectrum, from design, supply, and construction. So thank you so much. We just have a few minutes for questions. The first question that we got in was related to quality assurance. And so I'll just pose it to each of you. What is the impact, if you're looking at the NRC's Appendix B quality assurance requirements, as you look at supply chain, particularly Tier 2 and Tier 3 suppliers, what is the comparison between Appendix B QA requirements and the ISO 9000 series for your suppliers? And if you're interested in responding, feel free to just push the button on the mic, and anyone who has any thoughts they'd like to share on.
Michelle, I would like to share that for the ISO standards, so now that all the components are coming produced globally, and then as there will be more AP1000s, especially in Europe, there will be a lot of suppliers in Europe too. So it would be very nice if there is some kind of uniformity can be achieved, and then ISO standards with their addendum for the nuclear as additional can be matched to NQA1. I mean, at this time, it is not endorsed, as far as I know, anywhere that they are matching, and we are still looking for NQA1. We can do a lot of paperwork to make them, but then instead of every supplier is doing this paperwork, maybe expectation from the NRC, can we just, instead of only for ASME, can we also consider ISO as an equivalent?
Thank you. Any other companies that want to consider or provide any considerations on, use of the ISO standards? Thank you. Mr. Jolly?
You have to hold this one. Where is it? You said hold it. It's not lighting up. I think yours is covered, so I think.
Thank you. So the answer kind of depends, Michelle, I think, on what kind of suppliers and what the supply chain looks like, who the suppliers are. So if you start with Appendix B, you'll go through Reg Guide 1.28, you'll get down to NQA1, and those familiar, if you read NQA1 and you read ISO 9001, they clearly don't read the same. And that's kind of where the problem could start, depending on who the supplier is and what the supply chain looks like and what the mindset really is. There's a very basic premise in nuclear that those that have been in nuclear long enough, you know that the basic premise is that nuclear technology is special and unique. And I'd say by extension, nuclear projects are special and unique. And working on a nuclear project is a special thing. And if that experience is not there, and people think that there's some equivalency between the two standards, and they just know what to do, they don't know what to do. And if you don't know, you don't know. So it depends if there's familiarity and there's experience in the industry, in nuclear, and people know exactly what they're working to, and they have robust processes. Like our company, for example, we have our quality manuals and our procedures that comply with all of that, whether you're doing safety-related work, non-safety-related work, whether it's an NQA1 requirement in the contract or ISO 9001 in the contract. That mindset is there and that pedigree is there. But starting from scratch, if somebody thinks they can get it done with just an ISO program by themselves without the right experience, knowledge, guidance, et cetera, it's not going to work.
Thank you, Mr. Jolly. And that's, I think, really insightful in so many areas, because it really does take both the knowledge, the experience, and some background to be able to be successful. And with that, I think we are just about at the very end of this panel. Did anyone have, in our last moment, just any closing remarks or thoughts that you wanted to add?
I guess, I think Sean did a great job saying that this is a partnership and collaboration. I think all of us on this table just want to see nuclear succeed, and everyone in this room, that's what we want to see. So if we work at it together, yes, ASME would love to see everything being ASME, but let's be realistic, it's not going to happen. I'm a realistic individual, so let's just see the nuclear industry proceed forward and win for everybody.
Thank you. And with that, I would like to again thank all of my panelists and give a special thank you and shout out to Rachel, India, Manny, and Michelle, who did all of the background work to bring today's panel together. And let's just give a round of applause. Thank you, everyone.